Ramta Solutions, and welcome to your grade 12 maths. We are looking at the grade 12 functions. In this past paper series, we are looking at the Free State September 2023 paper 1 maths exam. Okay, so without any waste of time, let's open the paper and chow it. So chow again, book. Let's chow it. So I have pinned this. Let's open it. Perfect. So before I proceed, guys, if you are using a mobile device, please rotate your screen so you have optimized viewing. Okay, please rotate your screen so you have optimized viewing. So functions are beginning at question 4, and please, before we go any further, let me remind you guys of these instructions. All of them are important. Of course, I want to remind you of this. Clearly show all calculations, diagrams, graphs, etc. that you have used in determining your answers. Okay, this is very key. And also, instruction number 5, that answers only will not necessarily be awarded full marks. So that means show how you got to your answers where possible. Okay, some are straightforward, but those that are not really straightforward, show how you got to your answers. And do not remember that diagrams are not necessarily drawn to scale. And if necessary, round off your answer correct to 2 decimal places unless stated otherwise. So without any waste of time, let's get into it. Question 4. So I'm not going to remind you how these functions are like, but maybe, let me know, because in some of the videos we did, we always break down some of these things. Because I have been breaking down hyperbolas, let me not break it down this time. So let's get straight into the question. So here we have h of x equals -2 over x minus 2 plus 2. Yes, this is plus 2. Okay, moving on. 4.1, it says write down the asymptotes of the equations of h. They are x equals 2, right? And y equals 2. Remember, they are x equals p and y equals q. Okay, so as you can see, x equals negative p, right? X equals negative p. Okay, it is x equals negative p. Okay, it is x equals negative p. As you can see, p value here is negative. And when you look at this, it says to you, this function is shifting 2 units to the right. It is also shifting 2 units up. Okay, this is why our asymptotes are like this. This is your vertical asymptote and this is your horizontal asymptote. Okay, perfect. So we have 2 marks. 4.2, calculate the x-intercept of h. Let's see what is the x-intercept. H of x is equal to 0. Okay, that is you calculating the x-intercept. That means where there's y, you put 0. So -2 over x minus 2 plus 2 is equal to 0. This is -2. You multiply by x minus 2 throughout. It will be this. Okay, what do you have? -2 plus 2x minus 4 is equal to 0. So 2x is equal to positive 6. Therefore, x is equal to 3. Okay, x is equal to 3. Okay, now 4 marks. Ooh, we are cruising, yeah? Now 4.3, hold on, 4.3, before we go any far, maybe let me reduce it a bit. 4.4, remember guys, if you're using a mobile device, please rotate your screen. Okay, 4.3, it says we must draw the graph of, let me zoom this once more. This zooming doesn't work. Okay, so it says we must draw the graph of h, clearly showing all asymptotes and intercepts with the x. So we only have x-intercept. Let's confirm the y-intercept. So 4.3, let's get the y-intercept. That is h of 0. What is h of 0? It's minus 2 over, where there's x you put 0, plus 2. This will become, let's see, minus, this will become 3, okay? So this means your y-intercept is at y equals 0, okay? So let's try to plot minus 2, minus 1, 0, 1, 2, 3, 4. And then this is 1, 2, 3, okay? And then this is, let me say 4, 1, 2, negative. So we said it has shifted 2 units up. Here is it, 2 units up. It has also shifted 2 units to the right? It has also shifted 2 units to the right. Now, what is its x-intercept? It was x equals 3, if I recall. Here is it. Its y-intercept is y equals 3. This value here is negative. The numerator is negative. This means your curve lies between the second and third quadrant. Remember to write x and y. Label the x's. Okay? So when a is negative, your curve lies between the second and fourth quadrant. Okay? Perfect. So this is it, guys. This is your 4 marks. So you get your mark for shape, the points, and yeah, the points, x-intercept, y-intercept, and the asymptotes as well, and the shape as well. All right? So all your marks are yours when you do it like this. Okay? All the marks are yours. All right? So we are done with 4.3. Now 4.4, it says, determine the equation of the axis of symmetry of H in the form y equals mx plus c, where m is negative. What does it mean? It means you're looking at it where the gradient is negative. So you can begin it by saying this is y equals negative x plus c, because the asymptotes, they can either be positive x plus c or negative x plus c. Okay, they are either like this or like this. However, in this question, they want one with a negative slope. So axis of symmetry of hyperbolas are always have a gradient of positive or negative 1. Okay, so this question, they said 1 with a negative gradient. So our axis of symmetry, they pass through this point. Let me use a different color. They pass through this point. This point has coordinates 2 and 2. The x value here is 2. The y value is 2. Okay, so remember, axis of symmetry lines are passing through here and through here. So we only want one with a negative slope. Okay, proceeding. This, we say it's passing through the point 2 and 2. So where there's x, you put 2. Where there's y, you put 2. So this is 2 equals negative 2 plus c. Therefore, this means c equals 4. So we can conclude and say y equals negative x plus 4. This is the axis of symmetry with a negative slope. Okay. This is the axis of symmetry with a negative slope. Okay. Perfect. Now let's head to 4.5. So 4.5 says determine the range of h inverse plus 1. Negative h inverse plus 1. So here is it. Negative h, not h inverse, man. Negative h of x plus 1. What is h of x? We found that h of x was negative 2 over x minus 2, and then plus 2 close plus 1. What is this? Negative times negative is positive, so this is 2 over x minus 3. Negative times positive is negative 2 plus 1. So this then becomes 2 over x minus 1. It's 2, 1. So what is the range? So now with the range, we will say, as you know, with regard to a hyperbola, it says it can take all y values but not the horizontal asymptote. Okay, so by so saying, I mean, we say y is an element of real numbers. However, y should not be the value of the horizontal asymptote. What is the horizontal asymptote in the question we're dealing with right now? It is -1. So it will not take y is not equal to -1. Okay, it's like that. Okay, remember I'm saying our asymptote. For example, let me go to this function. For this function, it is basically saying it'll take all y values, but it'll not take it'll take all y values but not y equals 2, right? Because this is an asymptote, so the function does not exist on y equals 2. But now, with what we are doing, it doesn't exist at y equals -1. Okay. 4.6 says, determine the values of x where h of x is less or equal to 0. Let's go. H of x is less or equal to 0. Let's go back to the diagram. H of x is less or equal to 0. Here is our diagram. Remember, h of x is less or equal to 0. This is h of x, guys. Remember, this is h of x. When they say less than 0, it means y value must be negative. So where is that? It is below, it's basically below the x-axis. But pay attention, there's also equal to. So this means it'll include this. But be careful, do not say, as you can see, it seems like it's this value here. Don't be tempted and say this is when x is less or equal to 3. Don't be tempted. This function does not exist at x equals 2. So our answer is simply when x is greater than 2 but less or equal to 3. Okay? Did you guys get it? Going back to the sketch again, to the graph, let's go back. So, okay, this guy is acting up, but it's okay. We'll come back. So again, remember I said this graph, as you can see, as you go to the left of x equals -3, to the left of x equals 3, it seems we have a negative y value, right? It seems we have a negative y value, all right? But it doesn't mean that you must simply say it's x is less than negative, x is less than 3. There's a limit here. This function does not touch x equals 2. So since it doesn't touch x equals 2, what do we say? Since it doesn't touch x equals 2, what do we say? We have to say x must be, we must say x must be greater than 2, but less or equal to 3. Okay? Because at x equals 3, our curve is, at x equals 3, our curve is 0. Right? Or our function at x equals 3 is 0. Okay? Perfect. So we are done. Okay? So this is question 4 for us. So we are ready. Let's go to question 6. Let's go to question 6. I'm going to start it on the new page. Remember, question 5. Remember, guys, if you are using a mobile device, please rotate your screen. It's very important that you rotate your screen. Okay? So in the diagram, the graphs of f of x is equal to -half x squared plus 2x plus c, and g of x is equal to -x minus 2 are drawn. So I want to address some few things regarding parabolas or quadratic functions. The one we're given here is in the form y is equal to ax squared plus bx plus c. What we know, this is a y-intercept. Okay, and this basically tells us, one, when a is positive, it'll be smiling. When a is negative, it'll be frowning. Okay, also, it also looks at the dilation. Okay, it also looks at the dilation. When a is, the bigger the a, the wider the curve, but we will not look at that. So when we are given our function in this way, to find the axis of symmetry, okay, to find the axis of symmetry, we will say x is equal to -b over 2a. Allow me to call this f of x. It's easy that way. I want to call it f of x. Okay, f of x. So your axis of symmetry will be negative b over 2a. Okay, now your turning point. So your turning point will be, what is this? Negative b over 2a. That is your axis of symmetry. And you will substitute that axis of symmetry into your f of x. So in other words, it will be f of negative b over 2a. This will give you the turning point. Okay, this will give you the turning point. Okay, this will give you the turning point. All right, guys. Now, again, if you also want to find your range, remember your parabola is valid for its domain. It's valid basically for, not basically, it's like that. It's valid for all values of x. Whichever value of x you can substitute into your equation, it will always return a y value. Okay, so it's valid for all x values. So basically its domain is x is an element of real numbers. Now for its range, you must be careful. When a is positive, remember your function is smiling. This is what we call the minimum. So what will it be? It will be y is greater or equal to, what is this? Y value of the turning point. Okay, y is greater or equal to y value of the turning point. Okay, now when a is negative, this is when it's frowning. We call this a maximum. So we will say our range will be y is greater, sorry, less, not greater. As you can see, it's less, right? So it'll be less than all values equal to and less than this maximum here. So it'll be less or equal to f of minus b over 2a. Okay, this is all we need to know regarding the parabola when it's given in this form. Okay, perfect. Now let's answer the questions. So we have, let's see. So they say they are given in the form f of x equals negative half x squared plus 2x plus 6, and g of x is equal to negative x minus 2. Okay, they are drawn. C and E are the y-intercepts of f and g. Okay, oh, okay. Are the, what? C and E are the y-intercepts of, okay, that's true. C and E are the y-intercepts of f and g respectively. That's correct. The parabola has a turning point at D, I can see that, and cuts the x-axis at A and at B. Okay, I also saw that. A is also the x-intercept of G. DF is parallel. Oh, interesting. DF is parallel to the y-axis with F a point on G. Okay, with F a point on G. Okay, a point on G. Now, when you look at this, it seems like F has the same x value as D. Why am I saying that? Is because this line DF is parallel to the y-axis. So if point D, x value is whatever, point F, its x value will also be that of D. Okay? Perfect. So now we can proceed. 5.1. 5.1. Calculate the coordinates of D. I showed you. So we'll say 5.1.1. We'll say x equals negative b over 2a. So what is this? X equals negative 2 over 2 into negative half. What is this? This is x equals, I think it's positive 2. Alright? Yes, it's positive 2. Now we substitute this x value into f of x. So f of 2 is equal to negative half into 2 close square plus 2 close plus 6. Right? Alright. This is 10 minus 2. It looks like 8. Alright? It looks like 8. Therefore, we can say D has coordinates 2 and 8. Okay? It has coordinates 2 and 8. You can do this as well by completing a square. I don't want to do it. I'm okay with it. Okay, perfect. Moving on, 5.1.2, we're not going to complete a square. We are fine with this. 5.1.2, determine or calculate the distance df. Remember what I said to you. Value of y value of f, x value of f at this point is the same x value of d. So we are looking for g of 2. What is it? Where on g of x, where does x we put positive 2. So what is the y value? It's negative 4. So now what is df? So df is, we don't even have to waste time. It's basically f of what? It's basically f of 2 minus g of 2. What is f of 2? You found it to be 8. What is g of 2? You found it to be negative 4. So what is our answer? It is 12 units, isn't it? It is 12 units. Okay, so df is equal to 12 units. Okay, df is equal to 12 units. Okay, df is equal to 12 units. I'm saying this because you have a calculator. You don't have to do it step by step, but if you like, you can say this is 8 plus 4, which is 12 units. Okay, perfect. Now proceeding, 5.2 says to you, for which values of k will f of k have 2 positive roots? Remember guys, when they say 2 positive roots, for this one, I urge you guys to please be careful. This is the point here. This point here is y equals 6. Okay? So now when they say f of x equals k, it means k is a y value. Okay? It means k is a y value. So when we are looking for roots, we are basically looking for x values. Now the x values we are looking for must all be positive. You already know the y value here, and you also know the y value here. We said the y value here is 8, and the y value here is 6. Agree with me that as we move, let's say, below the x-axis, one root is positive, another is negative. Meaning if you draw a straight line, wherever the straight line touches these graphs, one x value is negative, the other is positive. Okay? Now again, even on the line on the x-axis. Now I want you to move above the x-axis until at point C. We still have the same thing. One is positive, one is negative. At point C, one is 0, one is positive. That's not what we're looking for. But above this point and below this point, that's what we are looking for. So what will we say? We will say this is when k is greater than, what is the y value at C? It's 6. What is the y value at D? It's 8. So our answer is simply k is less than 8. Sorry, k is greater than 6 but less than 8. Okay, and this is your answer. Okay, this is your answer. Okay, perfect. 5.3 says, given that f of x is equal to h prime x, determine the coordinates of the turning point of h. Okay, determine the coordinates of h. All right, now they're saying h of x. So which one is h? So wow, given that f is equal to h prime x, determine the x coordinate of the turning points of h. Now here, the question here that you have to ask yourself is this. Wow, f of x is equal to derivative. Whoa, this is interesting, right? H of x. Do you know what h of x is? We do not know as yet. Okay, we do not know as yet. Okay, do you? I do not know as yet. So we must determine the coordinates of the point of turning points of h. All right, that's fine. So I'm not even going to worry about this. What I know is this. What I know is that f of x, right? What I know about f of x is that, not f prime, just hold on. F of x is equal to h prime x. All right. So if this is the first derivative, to find the coordinates of the turning point of the first derivative, it means h of x must be equated to 0. So this is information you need from your differentiation calculus. All right. So they say that h of x has a function that varies with x is termed f of x. What is f of x? It is negative half x squared plus 2x plus 6. I repeat, they say we must determine the coordinates of the turning points of h. So if they say that, it means we must be looking for a cubic, and f of x, as you can see, it's a quadratic. So x-intercepts of a quadratic are basically x coordinates of turning points of a cubic. So we are good to go. Because this is the first derivative, we will equate it to 0 to find the stationary points, what we call the turning points. So proceeding, this becomes x squared minus 4x minus 12 is equal to 0. Okay? So this then becomes x minus, I think, 6 and 2. X minus 6, x minus 2 close equals 0, but 2 must be positive. Alright? So we will say x equals 6 or x equals negative 2. This is us now. We have answered the question. Okay. The key word here was to play around with this, and also on the question, they say x coordinates of the turning points of h. And we are given h prime x. To find these stationary points, x values of the stationary point, we must equate first derivative to 0. Okay. Moving on. 5.4. So 5.4 says, determine the value or values of x for where f prime x multiplied by g of x is less than 0. So something that I want you to know is this: f prime x will be negative x squared. I want you to see it. Oh, not negative x squared, negative x. Okay, it will be negative x plus negative x plus 2. Come on, buddy, what happened? Negative x plus 2. Okay, he's gonna come back. So it's gonna be, thank you. Okay, so it's gonna be negative x plus 2. Okay, I don't know what's happening now. Let me quickly do this. Okay, thank you. It's gonna be negative x plus 2. Remember g of x is equal to negative x minus 2. Do you guys get that? Negative x minus 2. So what you can do, you can draw a simple graph. For g, its y-intercept is at y equals minus 2. Its x-intercept, where will it be? Where will it be? It will be at x equals minus 2 as well. So here is it. What is this? This is g. Now, let's look for f of x, f prime x rather. Its y-intercept is at y equals 2. Where is its x-intercept? At positive 2. Do you guys see it? This is it. All right, this is it. So let me show this. This is f prime, not f in this. This is f prime. Okay, now to answer the questions, this says f prime x times g, f prime x times g of x must be less or equal to 0. So here what we are looking for, they must be either one must be positive and the other must be negative, and both, one or both, should be 0. So let's see. I'm going to start with this point here, x values, x-intercept. To the right, to the left of x equals minus 2. If you look at this, all of them will be positive. Do you guys agree? All of them will be positive. That's not what we are looking for. At x equals, what is this? At x equals, what is this? Negative 2. One is 0 and the other is non-zero. So we proceed. Now we're going to say we're going to go to the left of this point. As we go to the left of this point, until at x equals 2. 1 is positive, 1 is 0. So basically what we should be saying here, we should be saying, oh, this means x must be greater or equal to -2, but less or equal to 2. Okay, as you can see, in between this region where x is greater or equal to -2 and between x is less or equal to 2, this is where one or both are negative, or this is where one is positive and the other is negative, right? And then we are done. Okay, otherwise, by the way, I know there are those that prefer writing it in this way. X is an element of -2 included to +2 included. This is okay. All right, you can say this as well. Okay, so yeah, this is it, guys. I hope you understand this. It's important sometimes to draw your solutions. You see, when you do this, you get your answers as well. This is what the instruction was saying. Show all the graphs and stuff that you used to get to your answer. If you are like me, you think you should be drawing this. Okay? Perfect. Now, we are done with question 5.4. Now, let's head, question 5. Let's head to question, and by the way, let's thank SA Exam Papers for this paper. Question 6, let's see, we are given f of x equals a to the x and g, which is the reflection of f in the y-axis. Woo! Did you hear that? G is the reflection of f in the y-axis. Cool. We'll talk about that later. Let me not dissect anything as yet. So B has coordinates 3 and 3 times 1 over, or not 3 times, 3 and what is this? 3 and 3/8. Okay, so they say this B lies on F. The two graphs intersect at T. Okay, they intersect at T. Already you should know what point T is. For as long as they say this is a to the x, you must know you just put, where there's x, you put 0. Okay, where there's x, you put 0. Now what happens when you put 0? When you put 0, obviously this will become f of x will become 1. So you don't even have to waste your time. Hence this is 1 mark. Okay, so if you like, you can say f of x is equal to, remember guys, where there's x you put 0, it'll mean f of x is equal to 1. So T has coordinates 0 and 1. But let me show you. A, right? So f of 0 is equal to a to the 0, because x value here is 0. So what is this? This is 1. Therefore, T is 0 and 1. Okay? Perfect. Now, write down the coordinates. Calculate the value of a. To calculate the value of a, we will say f of x equals a to the x. Be careful to not use that intercept. Okay, you will use the other point that is given. Which one is that? You given point B with x value t and y value 3/8. Okay, and then so this will be, by the way, this guy should be 3 times, or 8 times 3 is 24 plus 3, he is 27 over 8. Okay, he is 27 over 8. Okay, he is 27 over 8. In case you worried, so this then becomes 27 over 8 equals a to the 3. Okay, equals a to the 3. By now you know that when you are solving for a, you will say cube root of this. Okay, so this will be cube root of 27 over 8, which is a. Therefore, we can say a is 3 over, isn't it? A is 3 over 2. Happy? Perfect. Remember, guys, we just said a is 3 over 2. Right? Good. Perfect. We are good to go. So this a is greater than 1. We are good. Hence, it's like this. Moving on. We're looking for we're looking for, we're going to do 6.3. So for 6.3, remember f of x was 3 over 2 to the power x. Now they said G is f of x reflected in the y-axis. So this is a point when it's reflected in the y-axis, it only changes the x value. So I will say g of x is basically f of negative x. Remember, when you reflect in the y-axis, x values change the sign. So this then becomes 3 over 2 all to the power negative x. Okay, if you like, you can also rearrange it and call it 2 over 3x. It's okay, right? 2 over 3 all to the power x. Okay, it's okay. You can say this. Let me just write it down. 2 over 3 all to the power x. Nothing wrong with it. Okay, nothing wrong with it. Okay, perfect. Now this is g of x. Now let's go. Now we're going to look at what is the next question? 6.4. It says write down the equation of the inverse of x, or f inverse of x, of course the inverse of f in the form y equals, it's 5. So 6.4, we will say f of x, we just found that it is 3 over 2 all to the x, right? All to the x. Now what do? We will then say y equals x, reflect here on y equals x. So where does y you put x, where does x you put y? Alright? So what do we say? We therefore say log in both sides. We'll have y equals log x base 3 over 2. Okay? Log x base 3 over 2. We are done. This is your inverse. So inverse of x is basically that. I can also write it like that. Log x base 3 over 2. Okay? Perfect. Now 6.5 says, for which values of x will f inverse, check this out, for which values of x will f inverse be less than 1? Did you guys get? For which values of x will f inverse be less than 1? Okay, for which values of x will f inverse be less than 1? So you need to ask yourself this. If I were you, or let me assist you, because I'm going to be honest with you guys. Some of us, we can write our answers directly, but because I want you to ace this, I'm going to show you. So I want you to start like this. F inverse of x equated to 1. Okay? Equated to 1. Now, when you equate it to 1, what do you get? You said this is log x base 3 over 2, right? So log x base 3 over 2 equals y. Let me go to the next page. So you then mean x equals 3 over 2, of course, to the power y. So this means x is 3 over 2. Right? So this means x equals 3 over 2. Okay? Now, you are asking yourself this. Remember, guys, when they say y value is less than 1, I want to show you something. If you were to look at this function, it is like this. Okay? It is like this. What is this? This is y value 1. Okay? What is the y value here? For f, for inverse, it'll be what? It'll be x value, right? So this is your, I believe this is your f inverse, right? I believe this is your f inverse, right? So now you ask yourself, they say, where will this guy be less than minus 1? So what you should be doing, but let me explain according to this when I drew. So what you should be doing, you say, oh, so here is it. When is it equal to 1? At x equals, when is it equal to 1? At x equals 3 over 2. Right? At x equals 3 over 2. This is when y value is equal to 1. Okay? So, but they say is less or equal to 1. So it means you must go down. Okay? It means you must go down. So don't just say, oh, x is less than, what is this? X is less or equal to 3 over 2. That is not true. When you say this only, It also means you are including the negative x values, all right? It also means you're including the negative x values. But in all honesty, guys, this function does not exist at x equals 0. So you must say x is greater than 0, but less or equal to 3/2. Okay, you must ask yourself that this must be when x is greater than 0, but less than 3/2. Okay, happy? Perfect. So, I think I shouldn't even be doing it in a different way. It's okay this way. It makes sense, right? So if you can also plot that for yourself. Remember, the point that was, what is this point B here? That was 3 and 3/8 will basically be, let me call it, I'm going to say B prime. I'm going to call it 3/8 and 3. Do you see it? It'll be somewhere, I don't know, not here. I didn't draw this to scale, but it'll be like that. This will be the reflection of this point on the line y equals x. You see that? So you say, oh, when I looked at this, so you go in that way. And this is how you know how your inverse looks like. Okay? This is you knowing how the inverse looks like. Okay? Or option two, you can say this. You can say, oh, they say x f inverse is less than 1. You can say this. You can say, oh, how about I say x is less, hear me out, x is, I'm going to say this, I have to be careful because we're saying this guy is equal to 1, all right? This guy is equal to 1. I will need to find his, in fact, I shouldn't be having an option 2 because I will need to find the x value that corresponds to this y value. Because here I have a y value, it means it was an x value. So what was its thingy? All right, so what do I need here? So I need to find from this guy here, I need to find him like I did here. Okay, hold on. Y value, I need to find his corresponding x value. And then I proceed in the very same way. So it's okay, I don't even have to do anything further. I can just leave it here. Okay, I can just leave it here because I have already used this. But what I wanted to say was I can also use, maybe let me introduce option 2. So option 2, I can say this. So for option 2, I can say, okay, so what is this? This is a y value. So it means I'm looking for an x value. So what is this? Remember, I have f of x equals 3/2 all to the x, isn't it? So now, if this is a y value, it means it must be an x value here. So I'm going to look for it. So this is f of 1. So what is this? F of 1. What does it represent? It is 3/2. Can you see that? It is 3/2. So now I can use f to get my answer. So when I use f to get my answer, I know that they said this value is less than 1. Right? They said this value is less than 1. Here I was looking for the value of x. So now I will say the value of y is less or equal to this value here. Okay? The value here we were looking for x. Alright, so now I'm gonna say, oh, for this to work, I must be saying, oh, when x must be, look at it, 3/2 somewhere there. So it must be 3/2, and then obviously you don't touch 0. But I'm using this wittingly because I know right now I'm basically using y values. Okay, right now I'm basically using y values. Okay, I'm basically using y values. But when I get to my inverse, I'm not going to be using y values. For inverse, I'm going to use x values. For inverse, I'm then going to say this. Okay? For inverse, I'm going to say this, but with an x. My mistake. For inverse, I'm going to say this, but with an x. Guys, whichever you are confident with, okay? Whichever you are confident with, must go for it. Okay? So with that being said, ours ends here. And I must say, if you would like to get in touch with us, you can visit us on our website, www.ramtasolutions.co.za. And you can also, in fact, on the very same website, you will see all these icons that you're seeing at the bottom of your screen. You will see them. If you click on this one, it'll open your email app, and then you can send us an email. In case, in fact, when you're looking for a tutor, you can email us. Or if you have been using our videos and they have helped you, you can also send us those well done messages or thank you. And also, if you want us to improve somewhere, you can also send. And if we are like waiters, we do appreciate a tip. Okay, we do appreciate a tip. And because you're watching this on YouTube, you can like and subscribe, of course, and share the video with friends. You can follow us on your social media platforms. So with that being said, guys, this is it. I'm going to see you next time. And trust me, after this video, the question paper that we're going to look at is from our beloved province, the Northwest Province. So, bye-bye.